Good midday, everybody. Welcome to the talk today. My name is Amy Lawton Rao. I'm a professor in genetics and biochemistry and associate provost for faculty affairs, and it's my pleasure to be the introduction to today's workshop. Tigers Advance in particular is a program that's near and dear to the hearts of everybody, Clemson, who's trying to make a concerted effort towards increasing inclusive excellence and is a partnership between the National Science Foundation, our university, to support a climate that supports gender equity, diversity, and inclusive excellence for all faculty, staff, and students. So you may hear some things that suggest that there's maybe a greater representation of women in particular, some of the efforts, but it's really meant to be more inclusive for all faculty, students, and staff. We are in our third year, and the impact of the partnership is clear. And is increasing. We're in our about halfway through the grant. In particular, there are several dedicated programs that people who have organized and participated in across the university, and I'll just name a couple of those. The Tiger Advocates Program is a program that trains faculty in how to recognize and reduce bias in work and in training environments, and that includes labs and the teaching environments and all the environments that help us do our work, help support our work. The Trailblazers Program, which is an intensive academic year-long leadership program that has sponsored about 25 faculty each year across colleges and resulted in both leadership development and increased recognition of faculty across campus last year. Includes an ongoing deeper dive into our mentorship programs within units and across campus. This year, our second cohort has been matched with mentors and is focused on professional development. And why you are here today is we have our Distinguished Speakers series as well through the Tigers Advance program. The Distinguished Speakers Series is now in its second year, and it provides opportunities for early career assistant and associate professors. Gives the opportunity to bring scientists from their disciplines to interact with undergraduate, graduate research students, postdoctoral scientists, staff, and faculty colleagues to help build networks supporting academic careers and professional development at Clemson University. So it's an important program. This series, like all NSF Advance programs, is a fantastic opportunity for all faculty to develop external networks by hosting scientists in their field, to develop relationships and collaborations that will help with their career advancement for the faculty hosts and all the folks that work in their research programs. It also provides an opportunity for faculty to demonstrate and cultivate leadership and mentorship to students, staff, and other faculty. Further information about the Tigers Advance program, including nominations for what I understand nominations are ongoing already for fall for this particular series, can be found on a website that is hosted through the Provost website. And at this point, I'm going to hand the mic over to Robert Onholt, who is our Director of Faculty Excellence in the College of Science.
Well, thank you very much, Amy. So our speaker is from North Carolina State University, and of course, the Clemson Tigers beat the Wolfpack. So I will be nice to him. I won't say, go Tigers. Go Tigers! Okay. So, Fred Gould is a University Distinguished Professor and co-director of the Genetic Engineering and Society Center at North Carolina State University. And I've known Fred personally for many years. In fact, he was one of the founding members of the Keck Center for Behavioral Biology for 20 years, which I directed at NC State. And we have interacted very extensively and become very good friends during the time. Fred has served on National Research Council committees where he addressed regulation of genetic technologies in agriculture. He received the Alexander von Humboldt Award for most significant agricultural research over a 5-year period. He received the Sigma Psi George Bugliarello, that sounds beautiful, this just sounds great, Prize for Written Communication of Science, and the Omax Gardner Award in 2012 for being the UNC faculty member with the greatest contribution to human welfare. He was elected to the National Academy of Sciences, and after his election to the National Academy, he started at North Carolina State University at the Center for Genetic Engineering and Society. Fred is well known for being one of the pioneers in developing disease-resistant crops via introduction of Bacillus thuringiensis into various plants. He has done beautiful work on co-evolution of species of moths, closely related species of moths that are also agricultural pests. He is currently very much involved in developing genetic methods for agricultural pest management. And this is where sometimes the friction comes in between the science, responsible science, and effects on society or perceptions by society. With that, Fred Gould is going to talk about responsible innovation in genetic sciences, past, present, and future. So let's give him a warm tiger welcome.
Wow, even for an NC Stater, you give me a warm welcome. Okay, well, that's great. I've had a great morning and yesterday interacting with folks from here, and look forward to more of it. And I'll also be giving another talk in 2 hours or something like that, and more a genetics topic. So Robert asked me to talk on this kind of general topic, and actually I had to really put together a new talk. So I have no idea if this will last for 30 minutes or 2 hours. So we'll see how that goes. I'll just end it at the proper time because it can end anywhere. Let's see if I can get this to move. Well, maybe I can't get it to move. Oh, pointed at the monitor. There. So before I get started, a little advertisement. All of what I'm talking about is part of this bigger program by the Genetic Engineering and Society Center. And just to say, we just got a grant for graduate training from the National Science Foundation. And we're taking in 7 to 10 new graduate students a year for 3 years who will be all the way from doing genetic engineering on their own to looking at public policy and so on. And it's about agricultural biotechnology, but it very much deals with some of these issues I'll be talking about. So caveats, I'm not an ethicist and I'm not a historian, but I'm going to take you to the past and to the future and all of that, but I have consulted with them. And also that the talk is not aimed at sort of giving you some kind of answer, but rather as exploring this topic, okay? So I came to this little drawing in coming up with this lecture to recognize, like a lot of us are sitting here doing science, and sometimes we see ourselves, okay, just leave me alone, let me do my science. But that never happens because your science is influenced by politics with a big P and politics with a little p. And politics with a little p is how you interact in terms of publishing and everything else. All those things in grantsmanship and all that involves a certain politics. But it's also influenced by politics at the bigger level in terms of what's Clemson funding these days and what is the National Science Foundation funding. And also, how does your science interact with society through that politics? But both of these are subsumed in culture, and that's more of what I want to get at in today's talk, because culture is the kind of thing that determines a lot about what politics evolves and what happens in your science, and actually even what questions you ask because of your culture. And I hope as I go through this talk, you'll see how those things interact with each other. So, one of the things to bring up in terms of that culture is, there could be this emphasis on progress. There could be an emphasis on autonomy in a culture, that each individual being on their own and their own agent, or there could be a lot of emphasis on equity and community. That differs among cultures, and all of those things will influence what's going on in the science and the policy. So, today, when Robert asked me to talk, this wouldn't have been what I would be talking about, but in some sense, the big gorilla in the room is Dr. Hay, who recently claims to have genetically engineered these twins, and what that is about, and what does that say about ethics and the policies and culture. And just to give you, it's sometimes been hard to understand what did he actually do. And the idea was that he was trying to engineer these embryos to become resistant to HIV. And so there was a known deletion in the CCR5 alleles that was naturally occurring and made people more resistant, or to some extent. But indeed, what he produced appears to be different kinds of deletions. And we really don't have any idea about whether those would even impact HIV. So, there's this whole kind of thing of this kind of rogue person being able to do this. And this, I don't know how that changed, but this is Jennifer Doudna's comment was, I was just horrified. I felt kind of physically sick. That was her response to hearing about this, right? This came from a New York Times article, and I want to bring this up about once that happened, all of a sudden now scientific institutions are trying to devise global safeguards. And we could think about what Dr. Hay did as this rogue thing, something to really be revolted against. But it's interesting to think about that in terms of the long term, in terms of how are we going to deal with human genome editing given this escapade compared to if it did not happen and we were a little bit better. There's a different kind of road that is developed when you have some kind of catastrophe like this than if you're going along with it slowly. And you could come up with the fact that it could be that we'll do better at regulatory things down the line because of this than without it. But what I always think sometimes is interesting from a New York Times article is to read what the comments are on an article. And I thought this one was kind of interesting because it gives you a picture in some way of the culture and the diversity of opinion. So this is Jessica actually from Switzerland. It strikes me as a fantasy to think CRISPR can be stopped. As these first babies demonstrate, the technology is too accessible and the dire desire and incentive of the upside is too great. Designer babies are coming. It seems better to me that they are born in daylight and not in back alleys, because there has been controversy among the researchers who set policy at NIH and in other places in terms of whether there should be a moratorium or how that should be moved. But at the end, this Jessica says, I don't envy those in charge of setting this policy. It's hard to think of a more loaded, thorny question, right? And I think it's not hard to understand where Jessica might be coming from. Mike says, those shouting, wait for the ethics to catch up, are stalling for time until Big Pharma can patent the process for themselves. There is that other part of our culture today where there's this total distrust of industry and what's going on there. Man from Norfolk, Virginia says, I love the idea of designer babies, superhumans. It's too bad that it will probably be gone before I'll be gone before. See, these new creatures are so common that we will wonder what was all the fuss about. And I want to bring that up because I said that this talk is about past, present, and future, and to think through where are we going to be in 50 years. So basically, the future is bright, don't be afraid. So you have all of these differing kind of perspectives. So it is that thorny problem of how do you address that? Do you go with if 60% of the public wants it and 40% don't? Well, then do you have an answer? Or are there other things in terms of actually looking at this technology and how it goes forward in terms of how you deal with it? How do you come up with policy on these things? That's the thorny issue. So what I want to do, though, is I just wanted to bring this up because it's so in the news, but what I want to do is reach back to history to look at how we dealt with something else in genetic sciences in the past and how we now, in the 21st century, look back on this episode that happened in the mid-20th century. And what were they dealing with and what was this like in their culture and the interactions? So this is Nikolai Vavilov. And when I was a graduate student and TAing a plant ecology course, I came across his work, and I slowly got captivated by the work he did on the origin and geography of cultivated plants. And it's very interesting. He came from Russia at that time. He was born in 1887. And he really was really a pioneer in applied evolutionary biology. He sort of became sort of a role model for me of what it would be to do this kind of work. And this is a compiled book that came out in English of most of his works, and I'm sure it's in the Clemson Library. And So what was so great about him? This is Nikolai Vavilov, who went from Russia to study in England with William Bateson. Among other things, William Bateson is credited with rediscovering Mendel and other things like that. And he basically did this from 1912 to 1914, and his motivation was to take this back to Russia and work to improve crops, because a lot of people in Russia were starving, and this was sort of a motivation for him to take this basic evolutionary biology and bring it back. And so he was intrigued by Mendelian genetics and crop evolution. And so he went back to Russia, and he convinced the powers that be, politically, to allow him to go and sample crops all over the world. Because his whole issue was he wanted to understand the origin and the diversity in order to improve crops. So these are just incredible trips he took throughout much of the world. And I have some pictures that he took while, in these great moments. He did go throughout the United States, especially looking at maize, and especially in Mexico. And think about this in the 1920s and so on. This is him in Mexico. He's a very photogenic guy. This is him in the Transcaucasus, which are now Georgia, Armenia, and Azerbaijan. This is him in Ethiopia, right? He got this funding to go all over the place to do this. This is him in Kabul, Afghanistan. Just think of this character doing all of these things. And so one of the things about him, he was very charismatic, and he got the backing of the government. And right during that time is when the Russian Revolution happened. And he came out of the Russian Revolution being able to get this funding, and he took all those seeds and everything back to his lab. A little lab, but. So he had this plant breeding institute in St. Petersburg. Huge. And he had people sorting these seeds, and he had a lab outside of St. Petersburg, or a research station to test these things. This is a picture of technicians sorting these seeds, and the whole legend about this is during the siege of St. Petersburg, of Leningrad, during World War II, the people who were working there starved rather than eat the seeds that were accessible to them. So there was this kind of cult of Vavilov in terms of trying to improve the living in the Soviet Union. And this just shows some of his work. He found centers of diversity of different crop plants in all these different areas of the world. And this just shows you the different types. So if you look at maize and tomatoes coming from Mexico and Central America, or potatoes from South America, and he determined these kind of things. And amazingly, these things were done that long ago, basically almost 100 years ago, and are still seen as very credible and very important, because these centers of crop origin are also the centers of diversity. So if you want to get germplasm, you don't want to look for corn germplasm up here. You need to go to the right places for the different things. And he set these scientific principles for how to do that kind of thing. And that basically was the first crop germplasm center, and today they're all over the world, right? So he really set this kind of thing in motion. And, this is a picture of the Svalbard, how do you say that? Svalbard? Seed vault in Norway, right? There's this one place up in Norway, up in the Arctic Circle, where they keep seeds in case we have a catastrophe in the US. And actually, some of the material that were put there from all these other germplasm centers, some came from Syria, and that whole germplasm center was destroyed, so they were able to get these back. But the whole idea was up there in the Arctic, and this just shows you a picture going back into the mountain to keep all these seeds cold. And the idea was, even if there was no electricity, things would be cold. Actually, global climate change is having an impact on that place. But all of this is the kind of outgrowth of things he did. I mean, that's why he was pretty special. But I guess I want to show about this idea of this culture and science and politics coming together. Think of this person being able to influence Lenin to fund him to do these kinds of things in that culture. But actually that culture changed. And this is, one part of the picture of Vavilov. This is the other piece of it. This was his mugshot in Saratov prison, where he died of starvation. Okay, so that's why I want to bring this story around, right? This guy was incredibly popular and wound up in prison dying. And this was just as a book written about some of the details about this. Vavilov had a nemesis, Trofim Lysenko, and basically there was kind of this battle between them, both incredibly charismatic personalities. So Vavilov believed in the evolution of crop plants, Mendelian genetics, pedigree plant breeding, germplasm banks. Lysenko's big claim to fame, he was a plant physiologist and he thought he could do everything using vernalization, right? For those who don't know, it's competence to flower based on cold exposure. So the idea was he could get plants that only did well in the more southern parts of the Soviet Union to grow in the more northern parts based on this kind of acquiring traits in a Lamarckian fashion. So this vernalization was really, was all about Lamarckian evolution and inheritance of graft traits. The idea is if you grafted a plant onto a rootstock, those seeds would inherit things from the rootstock. So very different kind of approaches. And when we look at what was going on in the Soviet Union versus the US in terms of wheat yield, you see this is the US, and I don't want to vouch for this slide, but the idea was basically that during that period in which Lysenko sort of basically took over, things slowed down in the Soviet Union. But, so what was the reason why Lysenko took away all that honor from Vavilov, and Vavilov winds up in jail and starves to death, and are there any lessons to be learned? Certainly, there's a lot going on here. And this is just a thing I'm using throughout this of a period of time, right? All the way up to the 60s. So Vavilov, as a real academic, promised new crop varieties in 10 to 15 years, right? We were talking earlier about hype and how you have to sell your stuff and stuff. He didn't. He said, this is what you might get. He recognized there were problems in growing some of this exotic germplasm in the Soviet Union. So he didn't overpromise, whereas Lysenko basically said he could solve these problems in no time flat. So winter wheat, he could turn it into spring wheat. And the other part was that actually Vavilov came from a very middle class or bourgeois family. So he had a certain kind of appeal to certain people, but not to others right after the Russian Revolution, whereas Lysenko came from a working class family and interacted a lot with farmers and people. These are photographs from Pravda, the newspaper of the Soviet Union at that time, showing him interacting with people and how basically the idea was that the Mendelian genetics was a bourgeois capitalist kind of approach to science and was going down the wrong way, whereas the Soviets were looking at it in a very different egalitarian way, where everybody has that ability to be whatever they can achieve, not based on their pedigree. And there were so many failures from the work that Lysenko was doing. This is Lysenko and his son out there, over a field of deterioration. But what's really interesting is if you look at Lysenko's history over this time, Lenin, although Lenin put a lot of stock in Vavilov, also started supporting Lysenko in the 20s. And then when Stalin came into power, he really backed up Lysenko. And there was still, though, periods where there was huge debates in the academia about Lamarckian evolution and all those things. And there was a point at which Lysenko was losing, and it seemed like the Mendelian geneticists would survive. But with Stalin's pushing, Lysenko's prestige went up. And this is actually a picture of Stalin looking over Lysenko as he talks to the Congress, the Soviet Congress in 1935. This was a statue that Stalin built, had built for Lysenko. Think of that. This is 1950. And then, even when Khrushchev came into power, he backed Lysenko as well. This is over a long period of time. And this is Khrushchev out in the field with Lysenko. And so from 1948 to 1964, Mendelian genetics was basically outlawed in the Soviet Union. And Vavilov wasn't the only one who went to jail. So basically, if you believed in Mendelian genetics, you kept it on the low. You didn't talk much about it. And this was not only in the Soviet Union, it transferred to China. I mean, not quite as strongly, but also to some of the satellite countries. Interestingly, this stamp from 1961, while Mendelian genetics was outlawed, was to Vavilov's brother, who was an atomic physicist who helped with the nuclear programs. In a certain way, there's, in terms of the whole communist kind of manifesto, in terms of dialectic materialism, there's nothing more clear in plant breeding and Mendelian genetics than there was in something else you couldn't see, couldn't have in your hand, than nuclear physics. So indeed, Stalin raised him to be the president of the Soviet Academy of Sciences in 1945. This is just 2 years after his brother died in prison. There's a lot of interesting interaction here, but I just want to show you some of the contrasts here in terms of what was going on, in terms of how politics influences science and influences people in science. And later, of course, they came up with a stamp for Vavilov as well. Why did the Soviet leadership throw their support behind Lysenko's pseudoscience? I mean, it would be one thing if Stalin did it for a while, but it kept going on, right? There was no positive response. He actually convinced Khrushchev. He was still coming up with things. Why would the leaders of that country follow in that? So this is where I bring up this interaction of culture, science, and politics. So in order to understand this interaction, it's useful to see what was going on in the Soviet Union and this long period of time when Lysenko's science was being supported by the powers that be. But it's also very important to see some of what they were responding to in England and the US. And so I want to bring in a cast of characters here that some of you may know well, many of them prominent geneticists. And this is why I think of what is genetics in society and what is responsible innovation in genetic sciences. And I'll go through some of this. So Galton was a cousin of Darwin's. And in 1869, just a decade after The Origin of Species is published, Galton publishes Hereditary Genius. Okay? It's a book basically about the genetics of intelligence and heredity, and a little bit talking about the need for eugenics and sort of self-direction of human evolution. Interestingly, Darwin read this, and this is his response. "My dear Galton, I do not think I ever in my life read anything more interesting and original, and how well and clearly you put every point. You have made a convert of an opponent." So think about that, Darwin and his cousin, and where all of this is going and why. In 1905, he actually wrote the work that actually defined eugenics and really moved this on. But he wasn't alone. We always think of this kind of eugenics movement in the United States. This is like at a county fair or something like that, where you're having people. And when you'd have these conventions of eugenics things, you'd see, they're thinking that it's all based on science, genetics, psychology, biology, anthropology, leads to eugenics. An interesting thing that was also posted at some of these things was the genealogy of the Galton, Darwin, Wedgwood family. which, as it says, a group of closely related family stocks characterized by outstanding capacities in philosophy, science, and the arts, right? This is all part of the same mixture. And there's Darwin here, and Galton, and Wedgwood. So this whole notion of that there were these families that were higher than other families. But it wasn't just in the popular press. This is Cold Spring Harbor Laboratories, which is where the Eugenics Record Office was from 1910 to 1940. Today we think about Cold Spring Harbor Laboratories, great places for doing research in molecular biology. Well, Galton wasn't alone. Pearson, I don't know how many of you know Pearson product moment correlation? Yeah? How many of you don't know what that is? Right, okay, yeah, you do? Trudy knows what that is. He was the founder of the Annals of Eugenics. This is somebody, we use his work all the time, right? This is the NC State Library. This is the first issue of the Annals of Eugenics in 1925 and 26. And then here's, I put a spacer in here that's 1953, 54. In 1954, 55, it switched to call it the Annals of Human Genetics. All right, what's going on here? All right, and this is Pearson. This is the first volume, I think the first volume, right? Annals of Eugenics, Journal for the Scientific Study of the racial problems, not of race even, of racial problems, right? This is the first article. Problem of alien immigration into the Great Britain, illustrated by examination of Russian and Polish Jewish children. Lots of correlations in this paper. So it's interesting just to think through what's going on here. All right, Punnett. How many of you don't know what a Punnett square is, right? You all know Punnett. Punnett writes this interesting paper about eliminating feeble-mindedness. And basically what he says is this is crazy. We should not try to do this because we all have some genes that contribute to this, and he does a number of mathematical assessments and says, we're never going to get rid of this kind of thing. It's not really scientifically plausible. Well, R.A. Fisher was troubled by this. So R.A. Fisher, R.A. Fisher invented analysis of variance, right? These are important, these are smart people, right? No lack. Elimination of mental defects, and he wrote a rebuttal to Punnett. I think I have the table which Professor Punnett has inadvertently supplied material for anti-eugenics propaganda, right? So think about all of these people and what's going on with them, all right? And then you have Muller, right? Won Nobel Prize for X-ray radiation and mutations. Muller was a communist, and he actually left the US and went to the Soviet Union and worked with Vavilov. But he actually was more of a problem for Vavilov than he was good for him. And in the end, he left and fought in the Spanish Revolution and then came back to the United States. But these are people who have such dedication, right? I mean, being in the Spanish Revolution on the side of liberalism and all. But Muller, while he was in the Soviet, wrote this book, Out of the Night, a biologist's view of the future. And this is all about kind of eugenic kind of things. And in the front is a little outline from Haldane, right? He went on a number of things, but he said if they adapt, the results will be as important as those of the Industrial Revolution. All right, that's a pretty strong statement. Okay, and Haldane actually did some apologies for Vavilov during his time. So it's these interesting combinations of individuals and their personalities. Oh, this is Haldane in Trafalgar Square, also very much interested in socialism. And then there's Dobzhansky, who was in a completely different realm as far as I can see, in writing books like Genetic Diversity and Human Equality. His whole thing was, yeah, we have a whole bunch of diversity. We don't want to narrow that diversity. That's what gives us a flourishing society. So interesting things going on here. And of course, he came from Russia, and was fluent, and he actually translated some of Lysenko's materials just so that people could see, I don't know, in my sense, how crazy it was, right? All right, so when we think about all of these things going on and what happens. So there was this whole interaction going on here, and how does that relate to the Vavilov and Lysenko kind of thing? Well, all of that stopped, or at least I shouldn't say stopped. When all of this was taken to the next step by Hitler, things did change some. Okay? But all of these things were interacting, and if you want to think about that in terms of what the Soviet response was, in terms of embracing Lysenko, it wasn't done in a vacuum. All of these other things were happening in the Western society, and that's the kind of science that was being done in the Western society. So who's got the upper hand here? What is this all about? And as I said, I'm not coming here to give you answers. I just want you to think about these things. I'm not sure why I put this in again, but, oh yes, just to think, of course, Hitler was done by 53, he was done in the 40s, but this continued, and not just there. So the Supreme Court had a ruling on Buck versus Bell in 1927, and this is the numbers of sterilizations that were done in the United States up until 1964. My state, North Carolina, continued that through the 70s. Basically that idea that you could get rid of imbeciles and you would have a better population. So there's something about that lived afterwards. So when you think about Soviet agriculture versus evolutionary biology, it's useful to keep it in the context of that, in terms of what was going on with these leaders. Especially Khrushchev is a hard one for me to still understand. So there were personalities, world politics, strong ideologies, and starving people going on there. And I just want to bring this to make a sort of segue into what I'm going to talk about next. But it was really interesting. Paul Lombardo, who's at actually Georgia Tech, gave me this slide, right? Think about that connection between the agriculture and the eugenics, and even more so this one here. This is, some of you may know Life magazine from a long time ago, right? That was a big thing, everybody sort of read that. Here's niblet corn, right? Eugenics in a cornfield. Bred right, grown right, right? So I just want you to think about that, all right? And think about this thing about culture interacting with science, interacting with politics. And my historian friend, in terms of talking about, says, Fred, you cannot go back and think about that world. You don't even know how to think about that world, right? How do you judge Fisher? How do you judge Dalton, right? If you read their works, they were dedicated to improving society. That was, they didn't just hate people, and that's why they wanted to do it. They thought that this was the sacrifice that individuals had to make for society. But what individuals? How do you make that decision, and how were those decisions made? And so I hope you can see how the culture is bigger than the rest of everything. It's really setting the stage. And I think we know that today, and I'll go into this more, just to see about how science has been influenced by our culture in the United States changing. I was talking to somebody earlier about how when I was young and I'd look at a newspaper for jobs, there'd be one page for jobs for men, and another page jobs for women. And those jobs for women weren't professors, right? And now, with all of that changing, if you look at behavioral biology and how behavioral biology has changed with more women studying behavioral biology, there's a big change in that. That's a cultural change. We wouldn't be doing things the way we are if we hadn't had that cultural change. So the question is, how do we go back? How do we evaluate that? And then I'll get into how we evaluate the future. So past, present, and future. I want to look at a present example and connected to a lot of stuff that I'm involved in. That's where this Ag Biofuse program comes in, is not thinking about the engineered human babies, but about engineering of crops and crop pests and so on. What is responsible innovation in using genetics in agriculture? How do you do that? And everybody knows that this whole GMO thing has moved into these camps, right? And thinking about that and how you do your science. I don't think I have to tell you too much about the no GMO people. Maybe but there's this. these interact by responding to each other, right? And they reinforce each other in not the same way as the Soviet Union thing, but there's something going on here, all right? So there's that kind of thing of we need GMOs to feed the world, and then there's the opposite, right? GMOs are going to poison the world, right? My sense is most of you don't have this opinion, so I don't need to emphasize that, but I guess I want to, again, show you this connection. So I was involved in a report for the National Academies looking at genetically engineered crops as of 2016, and we looked at where they were being grown. And it's just a little bit interesting. These are the 12 different crops at that time that were out there on the market. 10 of them were grown in the US, a couple of them in some places. China was always a very interesting example because mostly what they had was almost 100% BT cotton that kills insects. No genetically engineered rice or genetically engineered corn. They have a huge Greenpeace movement in China that's much stronger than the Greenpeace movement here in the United States. Sometimes people don't see that, think of China as doing that. But this is, again, where cultures are interacting. But an important piece is, look up here. There's the Soviet Union. How much genetically modified corn do they have? Zilch. And also, in all this culture wars and stuff like that in terms of fake news, actually, there's some connections being made between some of the fake news about the problems of GMO foods coming from Russia. So, but just to say, so I've worked on these genetically engineered crops for a while. This is genetically engineered corn that produces the BT, and this is the regular corn. So there's a real change in that. And, so just to emphasize that having that, especially in cotton, in developing countries, decrease the need for insecticide spraying. So this is just from China, looking at number of sprays per season. And you can see that red line is where the genetically engineered cotton came in. And you see the decrease in the number of sprayings. So if you look at that from the perspective of somebody who sprays cotton, and it's always guys, and they always spray in front of them so they could see what's happening. And of course, then they walk into it. And they wear very good protective clothing all the time. And they wind up in the hospital at the end of the year as the organophosphate has more and more of a cumulative effect. Well, it's clear that the BT cotton has been a healthy crop for them because fewer of them wind up in the hospital, right? So I could go on about all the positive things, but this overpromising is very strong. So this is a paper published in a peer-reviewed journal by scientists from Monsanto, looking at average US male yields. And you can see from 1980 on, this jagged line is the actual yield in those years. It's moving up. And this is 1996, and now they draw a red line, and they say, gee, it's increasing faster. And by the way, by 2014, we'll have new technologies, and it'll move like the green line if we don't have too much regulation. So when we were writing this report, we looked over the same data, and we found absolutely no relationship. Nothing happened in 1996 that was statistically, either in maize or cotton or soybean. And we had criticisms, of course, that, oh, well, if it wasn't for BT and these other transgenic crops, the yield would have flattened off because of global climate change or something like that. But if you look at wheat that has never been genetically engineered in the US, the line is the same. So what's going on here? What is that overpromising about? Oh, I just wanted to throw this in because some of you might find it interesting. This is what really happened with corn yields in the US, and that's why I showed you that one from the Soviet Union. It was flat for a very long time. And this is where hybrids came in, and this is where technology took off. But it's been going up for a long, long time. Hopefully it will continue, but the question is, when you say that genetic engineered crops are going to feed the world, is that where it's going to come from, or is it just part of maybe a technology that might help? So I want to bring up, I always love this quote by Jim Foley, I can't remember his first name. Anyway, GMOs have frequently failed to live up to their potential, not because they're inherently flawed, but because they have been deployed poorly into a complex social and environmental context of the real world. And we were just talking before about how it's easy to work on your favorite crop in the laboratory and see this great raise in how fast they're growing, and then you take them out in the field, and they don't do any better than a regular crop. So I want to bring up an article that was published in Science that was very interesting. Greater sensitivity to drought accompanies maize yield increase in the U.S. Midwest. It's a little bit backwards, but what happened here was before, without genetic engineering, conventional breeders, their goal was to develop drought-tolerant corn. All right, and everybody thought, we always hear about that, how genetic engineering is going to give us crop-tolerant, drought-tolerant corn. And it's a very complex thing to build a drought-tolerant corn. But these conventional breeders built corn plants that were more drought tolerant. Those plants, if put in the soil by themselves, as the soil dried out, they maintained themselves longer than the other crop. So you had a plant that was drought sensitive. But then those plants were actually commercialized, and they went out into fields, and the farmers took those, and they thought to themselves, gee, oh, this is an opportunity. So this is the cornfield. And if you look at a normal cornfield, when the farmer sets their planters, they set a certain distance between where each seed is put. And the reason is that on a normal year, if you put the seeds too close, even if it's a normal year, they'll suck so much moisture out of the ground that they won't have enough moisture for each plant, and the crop yield will go down. So there's an optimal distance. Well, what do the farmers think? Gee, now that I have drought-tolerant corn, I can plant the seeds closer together. And they did, and they got higher yield. And the plants were more drought tolerant, but the field was less drought tolerant. And that's where this greater sensitivity to drought comes in. So this is this kind of thing about, you know, our responsible innovation and selling things. So when we get something in a corn plant and we have drought tolerance, how does it come out? Some of the reason why that happened was because of policy, because of politics. We have crop loss insurance that is supported by the government. So for those farmers, it's more important to get the great yield in most years, and when they have a bad yield, right, then they have the crop loss insurance. So this did not come out very well. But I just want to give you an example from Africa. This is Burkina Faso, which was the first African country to take on transgenic cotton, and this had a Bt gene in it. And let me just say, I'm not trying to say that there's all these only problems with genetic crops. They're doing great things, but it's this idea that somehow they're going to be silver bullets. And so this was interesting in Burkina Faso when they brought in the transgenic cotton. This just shows the yield in the varieties that were engineered compared to the ones that weren't. So 18, 29, 19, that was the percentage increase in yield, which translates to even more increase in profits. So initially, the farmers thought this was great, but then the government gave back that cotton, sued Monsanto, didn't want to have anything to do with it, and it was very interesting to look at the reason. So this is Egyptian cotton, and the fiber length is very important. All right, the longer your fiber length, the better kind of materials you can make, you know, if you get those fancy sheets, you know, and all of that. And this is American cotton and Indian cotton. They're done, I mean, those are just names. That doesn't mean you don't grow them in different countries, but those are the names. But basically, what they had in Burkina Faso were this kind. And a lot of the Francophone African countries had that. So they were producing now, because they didn't do enough back-crossing to dissociate the Bt gene from the genes for fiber length, or I think that's what it was reason. They were producing cotton, more of it, and it was sitting on the market not being sold while the others were. So this is where these interactions come in terms of thinking about what you're doing and what are you giving to the world. And I'll have just one more example. I'm an entomologist. Fall armyworm. Fall armyworm has been a pest in the Western Hemisphere for long, long time, since corn started being developed probably, and it feeds on corn. About 5 years ago, somehow by trade or whatever, it wound up in Africa. And in that short period of time, that's the distribution in Africa now. All right? And so it's been a big thing that it's hurting African farmers, and that this is going to cause starvation. And this is the kind of response. Genetic engineering offers the only long-term solution. And so I started looking at this, and this is the USAID and other groups and some of the companies trying to bring this out. And it's really interesting because if you look at African farmers, 5% of African farmers grow hybrids. And if you look in the Western Hemisphere where the fall armyworm has been a problem for a long, long time, the only plants that have BT in them are hybrids. So what they didn't do for Honduras or Costa Rica, they're not going to do in Africa, as far as I know, unless there's some political will. So you have to question, and this is not an easy thing to do, moving genes into an open pollinated variety. And this is just show you the average kind of African farm, mostly tended by women with their children and hoes and whatever. They don't even have a seed system. How are you going to take that BT trait and get it into all these different varieties when you actually need at least 2 BT traits that are segregating independently on 2 different chromosomes, and you have to not wind up putting it into only one genetic background of this corn, because then you're going to have inbreeding depression right away. So nobody's talking about that. They're just talking about this miracle. So I just want to say, these are the kinds of things going on. So I'm going to talk in another hour or so about what we do. We work on genetically engineered insects, turning pests into good guys or whatever. And the idea that we can engineer one of these pests, the red ones that don't transmit a disease, throw them out there among the rest of them and have them take over the population. And maybe this could be great for malaria. And people are working on that. I'll talk about that. But the response to this, as much as that would save many lives, is in the shadow of what's going on with the genetically engineered crops. Because if we hate genetic engineering in crops, of course we hate it everywhere else. So I just want to show these these connections between all of our science and that cultural thing. And there's a target malaria thing, and I could go into more detail, but I'll let that go. But this is, in a sense, what this program is about, is to have our students who come from public administration, from communication, and from molecular biology and ecology work together on a problem. So hopefully, like if there was that kind of thing with that corn and drought tolerance, before that actually got to the farmers, these kind of assessments would have been done, sort of a systems kind of approach. So I said I want to talk about past, present, and future. So just a little bit to the future thing about these interactions. Basically, I come to this thing that science can tell us if we can do something, if we can make genetically engineered crops. Ethics can tell us if we should do it. But really, culture determines what our ethics tells us. You can get 5 ethicists in a room and have very different perspectives and very well thought out in different ways about these gene-edited babies, right? What is determining that? What determined what the ethics told those scientists during the age of eugenics, right? Why did they make those choices? It wasn't so clear. It's the culture that determined what those ethics were. What was the ethics in the Soviet Union? What was that determined by? And those cultures, I just want to indicate, are probably influenced by each other. And so even within the United States, the perspectives of the pro-GMO people and the anti-GMO people are impacted by each other. So how do you deal with that? And how do you deal with this? Different kinds of responses. I'm going to skip through this. The one I wanted to get at, I lost it. Anyway, I'll get to the very end soon. There have been these ideas that you need this global observatory for gene editing. I don't want to endorse this or anything, but the whole idea behind it, if I have this right, is to somehow enable more crosstalk between people representing different disciplines, political cultures, and normative frameworks, or their ethical frameworks. So the approaches currently taken for granted can be tested and recalibrated and look at dissenting opinions and so on. This is really hard work. So I guess I did have that last. I don't envy those in charge of setting this policy. It's going to be a very loaded story. And I guess my ending was that, indeed, think about, hey, doing this, and how did that change the discussion? And all of these things feed back on each other. So I'm not sure if that was in the longer term a good thing or a bad thing that that happen.